A very good evening, everyone. Standing right here is a group of four representing SM Sains Kuching Utara. I am Rohan Asyraaf.
I am Idzni Wafiq bin Zulhakim.
I'm anak Tomy.
And I am Darien Juan Kaba.
So now that the introduction is settled, let us begin discussing our topic on Sustainable Development Goals number 4, which is Industrial Revolution 4.0 in Chemistry Education, Malaysia. So for the introduction, in recent times, there have been some enthralling new developments in digital technology, especially in education. Some of these include eye tracking, virtual reality, and augmented reality. To give an example, virtual reality, which creates a three-dimensional digital world that you can fully experience. This creates a really exciting and promising tool for learning. So many studies have shown that virtual reality will play a vital and contribute substantially towards K-12 education, which is from kindergarten to 12th grade. The rapid climb of technology has also changed the way we learn, especially with the switch to online classes during COVID-19. In chemistry education, using technology can help teach things like chemical structures better. This paper looks at how new technologies are being used in chemical education today. So the aim of this study is to review any AI applications used in chemical education to be implemented further in Malaysia.
Before we begin review studies, I would like to add a few things beforehand. This review focuses on the use and application of emerging technologies in chemistry education with topics relevant to K-12 education in the era of artificial intelligence, AI, analytics, and the Internet of Things. The major research questions of the current studies include what kind of technologies have been produced or utilized to teach and learn chemical education in the classroom, what are the major applications, views, and aspects of measurement for the utilization of technology in chemical education, as pointed out from the analysis of studies in this review, and what are the outcomes of the application of technology in chemical education in terms of results and findings highlighted in the present literature review. Now, moving on to review studies. Restrictions on the publication year were applied. The timeline of the publication years was from 2020 until 2024. In addition, all students conducted in languages other than English were excluded from this review. In the current study, the elimination criteria were 1. Studies that do not involve chemical education, 2. Studies with views outside the current review focus, not related to fundamental chemistry topics, and 3. Non-English papers. When the following methods are applied, 32 articles through the searches in Google Scholar were identified. After initial screening, 21 articles were excluded. So 11 articles remain in this review.
So from the 11 articles, here are the results for 2020. So, first, Chen and Liu stated that the learning activities incorporated with the use of AR helped to improve the fundamental understandings of chemical elements and lead to long-lasting enhancement of individual interests. Next, Dunagan mentioned that a VR laboratory on infrared spectrometry was designed and evaluated. The results indicated no significant difference were observed in the attainment of learning outcomes between the experimental group and control group of students. The study supported the feasible use of VR technology for learning chemistry experiments, requiring institutions when distance education is required. The SimView system was designed by Gandhi to provide a new type of interactive laboratory learning experience. Student feedback indicated increased interest towards the chemistry curriculum topics regarding molecular chemistry and thermodynamics.
Okay, so right now, here are the results from 2021. Okay, so first is Molecular Web. Molecular Web, which is an open website providing interactive AR apps, was introduced for the exploration of molecular structures, reactivity, and dynamic interactions. Rodriguez mentioned that results from in-class and online surveys indicated good perceptions from users and supported enhanced learning engagement. Okay, so for the next one, comparisons were made between students learning in VR and real-life chemistry laboratories. Huao and Okita stated that clean-up behaviors were less common for students engaged in VR learning. Okay, so for the last one is Magic Cam. Magic Cam is a mixed reality system. It- The system was found to better satisfy the needs model when compared with other mixed reality experimental environments. Magic Cam also provides a safe virtual environment for students learning of chemicals.
So, for the results in the year 2022, Haruki Takahashi noticed that AI-driven virtual labs allow students to conduct chemical experiments in a safe, cost-effective, and interactive digital environment.
According to Jacoba van Erkel et al., in mixed reality, AI models are used to develop sustainable processes, optimize chemical waste management, and design eco-friendly solvents and catalysts contributing to greener chemical production. And according to Adiket Rat et al., in mixed reality as well, AI-driven models such as deep learning and molecular docking simulations are being used to predict drug interactions, design new molecules, and optimize synthesis routes.
Lastly, the results for 2024, according to Kati, AI helps students design experiments by suggesting possible outcomes based on chemical principles, encouraging critical thinking and problem-solving skills. Next, Bayer noticed that AI-based educational games and challenges make learning chemistry more engaging by incorporating interactive quizzes, puzzles, and augmented reality (AR) models that enhance conceptual understanding.
Okay, so now let's move on to the discussion. The integration of augmented reality (AR) and virtual reality (VR) in chemistry education has proven to be a valuable tool for enhancing student engagement and improving the learning outcomes. AR, VR, and mixed reality, which is MR, can help students better understand complex chemistry concepts and develop essential skills in a safe and controlled setting. So, with this, students can explore scientific equipment and chemical reactions in a virtual environment, which can help anxiety, especially when dealing with hazardous materials. For instance, AR tools have been used to stimulate chemical reactions such as the redox reaction between hydrogen peroxide and bleach, providing students with an opportunity to learn about experimental procedures without the risks associated with handling real chemicals. So lastly, AR, VR, and MR offers the opportunity for students to participate in virtual labs where they can conduct experiments safely without the need for physical chemicals or equipment.
So now, for the conclusion, to sum things up, the implementation of advanced technologies in accordance with Industrial Revolution 4.0 in chemical education should be introduced in Malaysia at a wider scale. This is to modernize learning approaches and improve student engagement. Advanced technologies such as virtual reality, augmented reality, and mixed reality provides innovative ways for students to explore complex chemical concepts and conduct experiments in virtual settings that replicate real-world laboratory environments. As a result, it allows students to learn and conduct chemistry-related experiments in a safer and more productive environment without any inconvenience for all parties involved. Overall, the adoption of these immersive technologies enhances student comprehension, minimizes experimental risks, and optimizes resource utilization, making chemical education more efficient, engaging, and accessible. So we've reached the end of our presentation. With that, thank you.